Last time we talked about the report that comes with any of the codon tree jobs. Now I want to walk you through some of the other files that come with any job. So let's find our job. We'll go into it a different way. I'll go into workspaces, click up here on this tab, and I'll click on my jobs. And this will open up the job page for me, and it's showing all the jobs that I've completed. Let me also note that if you have a lot of jobs and done a lot, you can see down here that right now I have over 2,000. I can click on this down arrow next to all services and filter on just the jobs I want to see. Codon trees, and let's look at the most recent job I did, which is this one, Endosymbionts, May 2020. And it was 10 genes, and I didn't do any duplications or deletions. So we need to view the job. When I click on it, the vertical green bar allows me to report an issue with the job or to view it. So let's click on the view icon. And once again, at the top, this shows me where the job is placed in my workspace. It's in my home directory in a folder called Endosymbiont Trees. And this is what I called it. Up at the top is how the job ID, how long it took to run, and if I were to open this, it would show me all the parameters that were used in the job and the things I selected. Last time we talked about the report HTML, but there are a bunch of different formats of the tree and the tree the way it's drawn in Patrick. You can get the portable document format, which is the PDF of the same tree. You can get a PNG, which is a portable network graphic. You can get the SVG, which is the scalable vector graphic, and that's a format that enables two-dimensional images to be viewed in XML pages on the web. We talked about the report. You can also get the Newick file itself. Now, this is an important file. The Newick file is the minimal definition for a phylogenetic tree. And if you want a tree that is publication quality, you're probably going to have to use a different program to visualize the tree and then get the picture of it. And I'll show you why in a second. So you'd need to download this file and upload it in either Figtree or the Interactive Tree of Life. I use Figtree all the time, and I'll show you how to do that in a later webinar. Another thing you can do, this is tree with genome IDs as opposed to genome names. You can click on it and then look at the possible things you can do here. I can view that tree. So click here, and this will show me the tree in the Patrick viewer right now. And this is the same one we saw yesterday. We've got the Buchnera here, the Blockmania, the endosymbionts of ants, Wigglesworthia, tsetse flies, and Raisa, which are the louse strains. One thing that you can do in Patrick, by the way, when you have these kind of views, is remember when we were creating genome groups and we were in the tree, clicking on these individual dots, I can click on a higher dot and it will select, see, these guys all have a check mark now. I could create a group from that tree, so that's pretty exciting. You can also see it as a phylogram or a cladogram. And that actually is a better way to see the support values for yourself. But if you wanted to publish this tree, which you wouldn't want to, because it's only 5 genes, and I'll show you how we can make this tree a lot better. So it is publication quality and also with better support and also looking much more awesome, not due to our program, but due to the number of genes that you choose and things like that. You couldn't do it with these colors, so you would have to take it elsewhere, as I said before. So let's go back to my jobs page. So we talked about these downloadable images of it, the report, the Newick file with the genome IDs. Now, when we looked at it, it had genome names because Patrick renders it. But if you open this particular file in Figtree or the Interactive Tree of Life, you'll only see the genome IDs. So many people want the names. How do I find the stuff with the names? Well, look, here's another folder, not brand new. So let's double click on the detail files. And oh my gosh, look what this opens. A whole bunch of other stuff. Genome analysis stats. Those are included in the report that we talked about earlier. And so it's in the, but if you want it to download it, maybe put it in a publication, that's a downloadable format for it. Actually, this is anything that ends in text is a better downloadable format. The genes per genome .text, that's the same thing that you saw in the genomes report. It would show you the number of genes, the number of single copy genes, and the filtered single copy genes per genome that were used in the tree. Next, the next file is the Nexus file format. And this is something if you wanted to use Mr. Bayes, we use RaxML. This is a format that's used by those kind of algorithms. Also, you can use Figtree. We'll use that to build a file. Partitions. Partitioning is a commonly used method in bioinformatics and phylogenetics that aims to accommodate variation and substitution patterns along sites. This is actually a very boring little folder or a little file. It's just showing you when you're looking at the different start sites in the genome where it started and where that position was. You can open it if you so desire. Sometimes people ask us for more information on the alignment. So the alignment stats text show the statistics of the alignment. And you know, we could even view that so you can see what it looks like. Anything that has a text button, we can view. So this just shows me the PGFAMs, the gaps, the information about each of these across the top. Okay, so I click the back button to go back. PHY is the phylet format, which is a plain text format that contains two sections, the header describing the dimensions of the alignment, followed by the multiple sequence alignment itself, if one wants to see that. RaxML command.sh is the actual shell script, shows the actual commands that were run. Aligned PDF is the portable document format of the tree with the tips aligned. Aligned PNG is the same thing, except it's a portable networks graphics format, and the scaled vector format, SVG, of the same thing. Here's the one I like the most. It's the tree with the genome names. That would be the one I would download and put into Figtree because I like this one. Oops, sorry. This is the RaxML is the information about the version of the tree and everything else. I can't imagine any biologist ever even looking at this, but the computer scientists might really like to see that, and it'll tell you the version of RaxML too, RaxML as well. And then the PX3 build codon tree log, it tells you exactly, if one wanted to see it, it tells you exactly all the steps that went on. And if there was a problem, this is something that we would open to look at to try to see what happened. So those are all the downloadable files. In the future, or the next little part of the series that we're going to do, I'm going to show you how to improve your tree. Remember when we looked at the report, we saw that if we eliminated some genomes, we'd get a better tree. So I'm going to show you how to go into your group and get rid of genomes that you don't want to see. Also, I'm going to show you how you can look at, using the protein family sorter, look at the protein families from the groups that you've created so that you can figure out if you need to do, first of all, how many genes you can use to build the tree, and also if you should use the duplication or deletion functions on particular group that you're looking at. So join me in that. And thanks a lot for watching this one.